Okay, so yesterday I introduced you guys the half angle identities, right? We all have those written down. Did we do any of the problems with them? No. Okay, great. Let's actually do the first two problems using those half identities. So I've got cosine of 15. So I have to use the cosine of x divided by 2. We're just going to see how far we can simplify that down. So my equation was plus or minus 1 plus cosine of x over 2. Now I didn't fill in for x because it doesn't get to be 15. It has to be whatever divided by 2 equals 15. So what number would that be? 30. Very good. So 30. So in my parentheses, I'm going to put, or in my cosine, I'm going to do 1 plus cosine of 30 divided by 2. Especially if it's something like this where it says find the exact value, we have to be given an angle that's like on my unit circle or else I'm not going to be able to solve it. So now I'm just going to simplify as much as I can. So I've got plus or minus 1 plus, what's cosine of 30? Anyone know off the top of their head? I think it's root 3 over 2. I know I'm asking a lot of you guys to look at your unit circle after a quiz, but yeah, root 3 over 2. Good. Okay. What I'm probably going to do now is simplify the top to get like denominators. So 1, if I make 1 have a denominator of 2, that's the same thing as 2 over 2. And so now I've got 2 plus root 3 over 2. All of that is over 2. It's got some big ugly fractions in here. The plugging in is not the hard part. It's the ugly algebra we have to do after it. So are you guys okay with me plugging into my formula 1 plus cosine of 30 over 2? We good with that? Then the next thing I did is I just replaced cosine of 30 with root 3 over 2. We okay with that? The step after that is I took 1 and made it 2 over 2 so I could combine these two fractions. That's why I have 2 plus root 3 all over 2. And then don't forget the or over 2 on the bottom. So there's a lot of over 2s we're doing. We have to make 1 be the same denominator as root 3 over 2. So I know 1 would be 2 over 2. If I didn't know that, I could think of, okay, what times 1? What do I need to multiply by 1 on top and bottom? It'd be 2 over 2, which is why it equals just 2 over 2. Now I'm going to multiply by the reciprocal. So I've got plus or minus radical 2 plus root 3 over 2 times 1 over 2. Which is not going to cancel anything out, which kind of sucks. But it is going to give me 4 on the bottom. So I've got root 2 plus root 3 over 4. And then for now, the last step I really need is just the square root of 4 is 2. Since this was all under a radical, I can just keep the radical on top by doing radical 2 plus radical 3 over 2. Whoop, come back. There we go. Now I got lazy and lost my plus or minus. Let's think about this for a second. Cosine 15, what quadrant is that in? 1, is cosine positive or negative in quadrant 1? Positive. So I'm just going to leave it positive. I don't need to carry the plus or minus with me anymore. Okay, let's do it again for tangent. So I've got tangent of 67.5. I got to plug it into my tangent equation now. But I got to think about what divided by 2 equals 67.5. What divided by 2 equals 70 or 67.5? Anyone know? Did you say? 135. Good. Is that on your unit circle? Yep. So I have to do cosine of 1 plus minus cosine of 135 and then 1 plus cosine of 135. We're going to leave this pretty ugly in a second, but that is root 2 over 2. So I've got 1 minus. Is cosine in 135, is that positive or negative? Negative. So that's going to be plus root 2 over 2. And on the bottom is going to be 1 minus root 2 over 2. I do want to go like we did with the other one where I get the what, like the numerator is going to be all one fraction, the denominator is going to be all one fraction. Again, it's going to be pretty ugly in a second, but that's going to be okay. So again, 1, if I want that to be a denominator of 2, it's going to be 2 over 2. So I've got 2 plus root 2 over 2 on top, and then 2 minus root 2 over 2 on the bottom. My radical needs to go all the way down. Yeah, let's multiply by the reciprocal, see if we can make it a little bit less gross. So that's 2 plus root 2 over 2 times the reciprocal 2 over 2 minus root 2. So the 2's cancel. And I am just going to leave it like this. 2 plus root 2 over 2 minus root 2. That's as good as I feel like getting today. Now, will this be positive or negative if I'm doing tangent of 67.5? Good. Why, Whitley? Because it's in the first quadrant. All right, that's pretty gross, but that's okay. Well, I need to move this up a little bit. Oh, that's still wrong. Okay, that's all right. All right. What I need to do before we move on is I got to teach you a couple more. I got to teach you double angle. So I taught you half angle identities. The last set of identities I think I'm going to teach you is the double angle identities. So right where I wrote my half angle identities yesterday, I'm going to write my double ones underneath them. I've got 1 for sine of 2 times x. I have 3 for cosine of 2 times x, and I've got 1 for tangent of 2 times x. So I just want to give you some spacing. So there are 3 equations that are the same thing as cosine of 2x. I could prove these to you, but for sake of time and for sake of your interest, I'm just going to give them to you. So sine would be 2 sine x times cosine x. That's the same thing. Hey, Neely. Bye, Neely. That's the same thing as sine of 2x. So if you see sine of 2x, we can replace it with that. Cosine, again, there are 3 of them. So the first one is cosine squared of x minus sine squared of x. The second one is 1 minus 2 sine squared x. And then the last one is 2 cosine squared x minus 1. Everyone good so far? And then the last one is tangent. It looks a lot like the tangent of the sum and difference, but I have to do 2 tan on top, 2 tan x, over 1 minus tan squared x on bottom. I'll leave it here for a second. Again, we're just going to use these. So we're just using these. You don't have to prove them. You don't have to do anything crazy. Just we're going to use them. Okay. The next 3 problems are like in one of the forms of the double angle or the half angle, and we just want to put it in the most simple form like this. It's going to be like cosine of 15 or tan of whatever, based on which formula and which identity we used. So the first one says 1 or square root of 1 minus cosine of 47 divided by 2. Does that look like one of the half angles or one of the double angles? One of the half angles, right? All the half angles have those square roots, so it's one of those. Which one specifically is it? If it was 1 minus cosine of 47 over 2. Sine, very good. So it's going to be sine of an angle divided by 2. Did I do this right last period? It's not sine of 47. It's going to be sine of 47 divided by 2. I have no idea if I taught this right last hour or not. I might have taught that wrong. Sometimes when you say things all day, I forget to say the thing right, and I truly think I taught this wrong last period. Oh well. Oh my God. Okay, so we have to do whatever number, or 47 divided by 2 is whatever number, and that's what we're doing sine of. So what's 47 divided by 2? Something 0.5. 20. This is embarrassing. What did you say? 23.5. Well, it's period F if you're watching. I'm sorry if I did that wrong in your real life class. All right, so sine of 23.5 is the same thing as what we just have right here. All right, we got 2 more we got to look at. Letter B says sine squared of 87 minus cosine squared of 87. Which one does that look like? It looks like cosine more than sine because it's being subtracted between them, but it doesn't quite look like that. Instead, I need to switch it so that the cosine goes first. Cosine squared of 87 minus sine squared of 87. So I had to factor out a negative here. I did not teach this one right last period. Yikes. All right. Now it looks just like one of the cosine ones, right? It looks like cosine 2x. So the biggest thing I forgot last hour was this negative. So it's going to be negative cosine of 2 times the number that's written there, which is 87. So 2 times 87 is going to be 174, I believe. Don't forget your negative. So since I had to rearrange it so cosine went first, it's negative. All right, last one before prayer cuts us off. This one, does this look like a half angle or double angle? Double, which one? Tan. And I'm going to do tan of 2 times the angle that they give me, which is 73. So 2 times 73 is going to be tangent of 146. All right, that's all that is for today. For those of you here on Friday, we're going to keep rolling with notes. For those of you not here on Friday, you are responsible for getting the notes. There'll be a video made, so you are responsible for watching it and learning it sometime between now and when we come back from spring break. I'm anticipating a test, not week after spring break, the week after. The week after.